This video will cover an advanced level of dynamic simulation, so you should first go through the 421 prerequisite playlist before attempting to solve this problem. I'll put the link to that playlist in the description. So I imported this assembly from a step file, and I'm going to put some of the components into appropriate subassemblies. So I'm going to crossing window and select these two components, and I'll right click and I'll do component demote, and I'm going to call this handle-anvil subassembly, and then I'll drag that up to the top of the list of components, and I'm going to ground this subassembly so that that doesn't move. I'm then going to select these two components, and I'll again do component demote, and I'm going to call this handle-lever subassembly. And really, this rivet right here I could either put into this subassembly or into this subassembly. I think I'll put it into this one, so I need to find that component, and I'll drag and drop that into this subassembly, and so now it'll treat these three components as one. And then I'm going to put this rivet into this subassembly, so I need to find that rivet, and I'm going to drop this into this subassembly. And let's turn off the visibility of these two subassemblies. Let's drag this up to here, and I'm going to turn off the visibility of both of these subassemblies that we've made so far. Alright, and then I have these remaining 5 components, and this one I'm going to leave it by itself, so let's turn off the visibility of that component. And so these 4 components, in the real world, these would have to be assembled at the time of the top level assembly, but for the purposes of dynamic simulation we can cheat and we can treat these 4 components as one subassembly. So I'm going to select those components, and I'll do component demote, and I'm going to call this as link plate subassembly, and I'll put that underneath my other 2 subassemblies. Let's turn on the visibility of all of our components. Alright, when we bring in a neutral format file like a step file, we don't have any constraints, and so we'll have to go through and put our constraints on the assembly. And so I'm going to constrain the axis of this pin to the axis of this hole. So I'll do C for constraint, I'll select the axis of this pin, and I'll put that to the axis of that hole. And so we see now that it rotates and it translates. Now I want to set it so that it doesn't translate, and so hopefully there will be a point in the center of this and a point in the center of this, or a plane. So let's go to the origin planes, and I see that there's an XY plane going through the middle of this subassembly, and I'll come down to this subassembly, and I see that the XY plane goes through the middle of this subassembly. So I'll do C for constraint, I'll do flush, and I'll select the XY plane of this subassembly, and I selected the wrong one, so let's control unselect that. It won't let me unselect. Let's just start again. So I'll do C for constraint, I'll do flush, I'll select the XY plane of this subassembly and the XY plane of this subassembly. And so now we test it out. It only has 1 degree of freedom rotation, and if we go into environments, dynamic simulation, we expect to see that converted to a revolution joint, which it is. Alright, then I'm going to do the same sort of thing down here. So I'll do C constraint, and I'll select the axis of this pin, I'll select the axis of this hole, and I'll say apply to that, or let's just say OK for now. And I'm going to go to the modeling or the assembly tab, and I will go to the press plate, and I'll do C for constrain, I'll do flush the XY plane of the press plate to the XY plane of the handle that doesn't move, the subassembly. We'll say OK to that, and if we look at it in dynamic simulation, we have a revolution joint, which is what we expect. And then I'll do a constraint between here and here. So I'll do constrain, and I will select the axis of this pin, and I'll select the axis of this hole. I'll say apply to that, and actually let's just cancel out and go back to the assembly tab. And so then I want the XY plane, and I'm going to put it on this moving component, the XY plane of this moving component to the link plate. So I'll do C for constrain. I'll do flush the XY plane of the handle lever to the XY plane of the link plate subassembly. Now if we test this, so that plate goes with the handle, and now we need to put the constraint on here. Now in the real world, or in our assembly too, there is clearance between these components. So this link plate subassembly can twist a little bit going around in this direction or vice versa. And so if we do an axis to axis, that would be an over constrained condition. Now I think Inventor is now smart enough to figure that out, and it will automatically do a point line, but I would normally just go ahead and do a point to an axis. But let's see what will happen if we do the constraint. So I'll do constraint, I'll do this axis to this axis, and we'll say OK, and it should give us a point line. And so it did give us a point line. Now in earlier releases of Inventor, it would have given us an error, and it would have told us it was over constrained by 1 degree. Let's do it the way we would have done it in an older version just to see. So in an older version of Inventor, we would do constraint, we would do one of these points. So if I select a circle, that'll get the center point of that circle, and then I'll select the axis, and that gives us a point line joint. So either way to get those in, and we test it out, and we see that everything moves now as we would expect it. Now I want to crimp a part in here, and it's going to be between this face and this face, and my maximum amount of force is going to be when these pins right here are lined up in a straight line. That's the minimum distance between here and here. If I continue on, it starts to pull this press plate back, so there's less force. So the maximum force is where that distance is at its minimum. So let's finish dynamic simulation. We'll go back to the assembly environment, and I'm going to put an angle between here and here of 0 degrees. That is when these are lined up. Now actually this edge right here is a slight angle to the location between the holes, so I think I'll use this edge up here. So I'm going to do constraint, and I will do an angle constraint, and I'll leave it on the explicit reference vector. And I see that the angle is coming in radians rather than degrees. That's because we imported a step file. Let's cancel out of this for a moment, and I'll go to the Tools, Document Settings, and for the units, the angle units, I'm going to set that as degrees. And then we'll go back and we'll do our angle constraint between this face, and it's revolving these two relative to this cylinder, and we'll say OK to that. So that is where these 3 pins are in a straight line, or the minimum distance between here and here. Now notice though that these covers on the handles intersect each other. So we would need to make some adjustment to these covers in order to avoid that intersection. And then also down here we need to make sure that there's no interference between here and here, and it looks like there is no interference there, so we're okay there. But if I come over here, I see some interference right in here. So we either need to move this gap down, or we need to move this face up. And I think what I'll do is I'll move these faces up. And let's see what else that we have. Oh, also let's look at this in a section view. So I'll go to the XY plane, and I'll go to the view tab, and I'll do a half section. And so I also need to look at these pins and make sure that there is clearance between these pins. Right now it's in interferent condition, and so we're going to need to bring this slot down further so that that's not in an interfering condition. See, when this is a straight line across here, there's interference from here to here, so we'll need to increase the length of that slot. Let's go ahead and name this constraint. So I'm going to name this, let's call that closed. I'm going to call that closed position, and I'll say suppress this. And what I may end up doing is just putting a limits on here, a minimum and maximum limits on here. But I know that I need to bring this slot down further. And we know that we need to bring this up some so that it doesn't interfere right there. So I have some clearance here. I have clearance here between these pins. And let's just suppress this for a moment. So I'm going to suppress this one. And if I bring this up into here, and so I have clearance between here and here. This line back here is actually on the back side over here. So I do have clearance though between the diameter of this pin and this face, and the same clearance over on the other side. So we need to address some of these issues. I think the easiest one to do first is to move these faces up. So I'm going to find that part and we'll edit it. So I'll put this back at the closed position. So I'll right click on this and unsuppress it. And then I want to open up this part. So I'm going to do shift right mouse and put my selection filter on part priority. And I'll open up this part. And because this is an imported component, we don't have a history tree over here that we can edit. So we'll have to use direct editing tools. Let's look and see what this distance is from here to here. So if I go to the inspection tab and I do measure, this distance from here to here is 0.25. And I think I'm going to move then the whole slot up 0.25. So I'll go to the direct editing tools and I'm going to move some faces. So I'm going to move this face and this face and this face and this face and this face, and I'm going to move those all along this axis, so you can pick which axis you want to move along. The axis that is active is the one that I want to move. I'm going to drag this way, and let's put in 0.025 as the distance that I want to move. So that moved that entire slot up a distance of 0.025. I will go back to my assembly and see how that looks in the assembly. So I'll come down here and I'll see that that just barely gives me some clearance in between here. I may want to increase that just a bit to ensure that I have clearance. But keep in mind, this can also be used as a limiting factor so that the operator cannot go too far. And actually, this rotation up here will also be a limiting factor on this slot. Let's move this up just a bit more. And so I'm going to go back, and I'll go back to that move, and I'll say edit, and thought it would give me the distance here. I'll double click on that move, and I'm going to tell it 0.035. I'll put 10 more thousandths, and I'll save that. I'll go back to my assembly and I'll look at this. Okay, so I increase that clearance in here a bit. I want to bring this slot down, and so that's got to go at an angle, so it will be curious how that is going to work. So I'll go ahead and open up this component, or this part, so I have it. Right now I have it on part priority selection filter, so I can open up this part, and I'm going to then go to direct edit. So instead of move, I need to do rotate, and I will select this face. I want to rotate this face, but I want to rotate it about this hole back here. So I'm going to click for locate, and I'm going to select this cylinder, and then I want to rotate about this axis, so I'll select this axis, and I'm going to rotate that down, and I'll just rotate it by some amount and look and see how it comes out. And so it tells me it couldn't move that face. It has some dependent faces on that, and so we'll edit that, and we'll also select this face and this face. So I'll go back to my face selection, this one and this one, Okay, I need to get my location again. I want to rotate about this cylinder, and we could just pick either one of these circles. We don't necessarily have to have that cylinder. And then I want to rotate about this axis, and it gives me an error again, so I need to regroup and figure out how we're going to move that face. So I did a little bit of experimenting, and I want to put a rough value of how far we actually need to rotate that. So I'm going to do S for sketch, and I'm going to select the assembly XY plane, and then I'll do project. I'm going to project one of these circles, and I'll project this circle and this circle, and then I'm going to do a line from here. I want it over tangent to this line. Let's go ahead and do this one tangent. So I'll do this one tangent to this circle, and then I'll click and hold the mouse button down. Well, that's not where I thought that would give me the tangent. We'll go back up here, and then I will drag this point back here, and we'll do tangent, and we'll get that angle between here and here, and we see that that's 0.072 degrees, so I'm going to make that 1 degree total. Now another thing that I did, and I'll finish this sketch, and I don't need that sketch now, I just created that to do that measurement. So let's delete that sketch now. I also went into the individual part, so let's open up this part again. And again, this was an imported step file, so I had to go to Tools, Document Settings, and set the units to degrees. I'll save it with those settings, and then I'll go back to the 3D model and select all of the faces on this slot. And then for the location, I will select the cylinder, and now if I drag this, so now I can drag that slot. So there's the preview, and then for the angle I want to go -1 degree. So that's going to move that down 1 degree. And then if we need to edit that, we can always go back and edit this to change that. I'll save this, and I'll go back to the assembly, and we'll look at this. And so now we see that we have clearance between the pin and the slot right here, but it can't move any further than that. So once it moves 1 degree more, that would stop it from moving any greater distance. So this ends up being a limiting factor. This ends up being a limiting factor here. And then this edge right here would come in contact here at some point. So we can build some limiting factors into our mechanism to try to prevent the operator from doing something with the tool that isn't intended. And if I right click and I suppress this constraint, in the same token, when we open this, when this comes in contact here, that limits how far this can open. And so we might put that distance such that that can't open too far. We need to open just far enough to put the part in here that we're going to crimp. And then the operator, if it doesn't come, say, down to here, the operator can pick this up with one hand off a bench. They don't have to use two hands in order to get this handle close enough to this one where they can get their hand around here. So think of those design considerations when you are designing tooling. Now, I think the one issue with this I'm just going to ignore, and that is the cover for the handle where this interferes. As it comes up, well, when this is in a straight line here, yeah, so we need to cut some off of this, the cover of this handle. If I turn off the covers of the handle, I turn off this visibility and I turned off this one, so the metal parts themselves, this goes inside of this part, so there's no interference there, so that's not an issue, and there's a little bit of clearance between those two, so that is able to operate. We just need to edit the covers in order to keep those from interfering.